Hey everyone, I'm going to walk through how to create an efficient frontier using Python as a coding language. I got to give big credit to Ricky Kim because a lot of this code, especially the calculations and algorithmic code, I found on a tutorial of his, which I'm going to link that in the description. He provided a Jupyter notebook to walk through, and it was a big help for me. So, an efficient frontier is a way to determine how to weight a portfolio of specified stocks or securities to maximize the return at a given level of risk. This is in the modern portfolio theory developed by Harry Markowitz. If anyone wants to learn more about that, I'd recommend looking up Harry Markowitz in the modern portfolio theory. But to get into the code of this and kind of how it's built, first of all, you're going to want to do all of your imports. Here we're using pandas, numpy, matplotlib, seaborn, quandl, and scipy. These are all basically for financial calculations or for graphing. And then down here, this is going to configure your Jupyter notebook to display the matplotlib in higher resolutions. Okay, so the first thing that we're going to want to do is select the stocks for our portfolio, and we're going to get stock data using Quandl. So you're going to go down here, you're going to punch in your API and have this data because you're going to want your date, the ticker displayed, and what the stock closed at. So for the stocks that we're going to use, we're going to be using Advanced Micro Devices, which is the ticker's AMD. Activision, which ticker is ATVI. Intel, which is INTC. And then lastly, Electronic Arts, which is EA. So if you didn't already get the gist of this, they're all gaming stocks. So it's not a very diversified portfolio. So we'll end up seeing how this efficient frontier curve looks. And then to check to make sure that the data went through or that the Quandl is working, what we can do is down here type in data.head with an empty parenthesis, and that will be able to tell us if it's collecting data right. So we're going to go up here, we're going to run the imports. That went through. We're going to go down here and hopefully we see some data. We do. So since this is it was .head, it's only going to bring up the top 5 results. So all the other companies are going to be down low. But right now the index is just 0, it's just integers from 0 upwards. We want to change this, and we want these dates to actually become the index. So to do that, we're going to run this code right here, which is actually going to create a data frame, and it's going to set the index to date. So when we run this with the df.head, we can see that now the index is the dates. This will make organization of our data a lot easier. Now the next thing that we want to adjust in our data frame is we want to do this pivot command and make the columns equal to ticker. So this is going to change the column names to the companies which we are analyzing. So if we run this, we can see now that the companies are at the top of the columns. So now before we create the efficient frontier, I want to see the stock prices over time and how they compare to each other. So this code right here is going to plot the stock prices over time. So we can see here they're kind of all over the place. You can see sometimes they move together, sometimes they don't. But all in all, this graph is not too helpful for analysis. So what we want to do to make this a little bit easier is actually look at the percentage change in price. Another way that sometimes that analysts will look at the changes of stock prices using a logarithmic graph, but we're just going to run the percentage change table. So you can see here that's what we're doing here is we are going to change the table into a percent change. And then this is all of the parameters for our table. So when we run this, you can see now it's much easier to tell which company is moving against who in terms of percentages rather than a dollar value. We can see Advanced Micro Devices, AMD, had a really big spike into the beginning of 2016, and they had a pretty large negative drop about halfway through 2017. Other than that, the next biggest move is probably by Activision here in 2017. So now to start generating the efficient frontier, we need to generate a lot of randomly weighted portfolios. So there is a way to do this to actually optimize the portfolios so you're not creating solely randomly weighted portfolios, but this is the way that I'm choosing to show. So essentially we're going to generate thousands of portfolios with random weights and then run it through the algorithm, which Harry Markowitz developed, to determine which of those portfolios is going to generate the most return for the minimal amount of risk. So the following code takes the sum of mean returns generated by the stocks in our portfolio for an average trading year, which is 252 days. It also calculates the standard deviation of each portfolio. So if we run these, and then this next box that I'm going to run right here, this determines what our risk-free rate is. It's going to determine the number of portfolios generated, which I said is 25,000. And then it's also going to run the variables for the covariance, mean returns, and returns as the percentage change. Okay, so this next box is probably the most intimidating, and it's also going to be what actually generates our graph of the efficient frontier. So essentially what it's going to do is it is going to print off our portfolio allocations for the maximum Sharpe ratio portfolio and also for the minimum volatility portfolio. And then right down here, this is going to actually plot our efficient frontier through matplotlib. So if we run this, and then down here we actually display it. It's got to think for a second. And there it is. So of the 25,000 portfolios which we generated, for the maximum Sharpe ratio portfolio, we have an annualized return of 38%, annualized volatility of 23%, and our allocation, you can see here, places most weight in Intel and the least amount of weight in Advanced Micro Devices. For minimum volatility, the annualized return is 24%, annualized volatility is 18%, and for allocation, we put by far the most in Intel and by far the least in Advanced Micro Devices. Advanced Micro Devices only being 0.14% of the portfolio. This makes sense. As we saw earlier, the percent change spikes in Advanced Micro Devices were much greater than everything else in the portfolio. I wouldn't be surprised if we were using optimized portfolios, not going further than just the randomly generated portfolios, but to actually optimize them. If for the minimum volatility allocation, Advanced Micro Devices was just at 0, and the majority of the weight was in Intel because Intel has the most stable pricing of the 4 stocks. Looking at this efficient frontier, the shape here does look a little bit goofy compared to other efficient frontiers. And I think that that's because the 4 stocks that we chose are all in the gaming industry and they're not very diversified. So the Sharpe ratios and volatilities of these 4 stocks are pretty tightly clustered versus if we had a more diversified portfolio, I think we'd get a more natural looking or, the more stereotypical looking efficient frontier curve. But anyways, thanks for watching this walkthrough. And like I said, I'm giving a lot of credit to Ricky Kim for the code and the tutorial that I watched, which he posted in a blog post. So everyone, thanks for watching. This was the Efficient Frontier.